Okay, so let us see the examples on curvilinear motion. A motorist is traveling on a curved portion of a highway of radius 400 meter. Okay, so radius of curvature rho is given there at a speed of 90 kmph. So velocity 90 kmph. Okay, speed 90 km, sorry. Then brakes are suddenly applied, causing the speed to decrease at a constant rate of 1.2 meter per second square. Determine the magnitude total acceleration of the automobile. Okay, immediately after the brakes have been applied and after 5 seconds. Okay, so what is given? Let us see it. Radius of curvature is given, speed is given. Okay, and acceleration is decreasing at rate of 1.2 meter per second square. So what is this, an or at? Yes, it is at. Okay, determine the magnitude of total acceleration of the automobile immediately after the brakes have been applied and 5 seconds later. Okay, so right, so take time t is equals to solution, take time t is equals to 0 at the instant when brakes have been applied. Next, so v 90 kilometer per hour, so it's 25 meter per second square. At minus 1.2 meter per second square, minus because the speed is reducing, so first part a at t is equals to 0, an v square by rho v 25 by rho, it is 1.5625 meter per second square. An is there, so you can find acceleration at t is equals to 0, square root of an square plus at square. Okay, an we have just determined, at is given, so a is equals to 1.97 meter per second square. And b part, say at time t is equals to 5 seconds, so tangential acceleration at minus 1.2 meter per second remains constant, it is uniform. Okay, so it is set. So next, v is equals to u plus at, this equation we are using, so we will be finding final velocity. Okay, after 5 seconds, because this acceleration or deceleration rather is a constant one, so after 5 seconds the velocity is 19 meter per second. Earlier it was 25 meter per second, 25 meter per second square, my mistake. So 19 meter per second. So normal component of the acceleration at time t is equals to 5 second, a n is equals to v square by rho again, but now this v is 19 by 400, so this comes out to be 0.9025 meter per second square. Now a is square root of an square plus at square, square root of this, so a is minus 1.502 meter per second square. Okay, so acceleration at t is equals to 5 seconds, and acceleration at t is equals to 0 seconds is this 1.97, and here it is 1.5. Okay, so the next question now, a car travels along a depression in a road, the equation of depression being x square is equals to 200y. The speed of the car being constant equal to 72 kmph. Find the acceleration when the car is at the deepest point in the depression. What is the radius of curvature at the depression point? So this is the diagram for it. So this is the depression. Okay, and what is given? Travels along depression. The equation of the depression is given by x square is equals to 200y. So equation of this curve. Okay, the speed of the car being constant equal to 72 kmph. Okay, 72 kmph. Find the acceleration when the car is at deepest point in the depression. The car is here, we have to find at and an. Okay, what is the radius of curvature at this point? Okay, so the point O being the deepest point on the depression, say consider this to be the origin, speed 72 kmph, so 20 meter per second. Okay, since the speed is constant throughout the curve, the tangential component of acceleration is 0. Okay, so what is said, speed of the car being constant equal to 72 kmph. Okay, so what is the speed of the speed is constant throughout the curve, so tangential component at is 0. Okay, so at is equals to 0. Next, so total acceleration at O is normal equal to normal component an. So a is equals to an only. An is equals to v square by rho. Rho is again 1 plus dy by dx bracket square whole to the power 3 by 2 upon d2y by dx square. So let us find it. So we know x square is equals to 200y, so y is equals to x square by 200, dy by dx it is x by 100. Okay, d2y by dx square it is 1 by 100. Okay, so dy by dx at 0 0 is 0 and d2y by dx square at 0 0 is 1 by 100. Okay, so rho is equals to, put these values here, 1 plus dy by dx bracket square whole raised to power 3 by 2 divided by d2y by dx square. Okay, so 1 plus 0 square whole raised to power 3 by 2 upon 1 by 100. So this is equals to 100. So an is equals to v square by rho. So rho is 100, v is 20. Okay, v is 20. Okay, yes, 72 kmph now, so that is 20. So an is equals to 4 meter per second square. A is equals to an is equals to 4 meter per second square as t is equals to 0.